TensorFlow and PyTorch are the two most popular automatic differentiation libraries. In fact, that is primarily what they are. So we might think of TensorFlow and PyTorch as being deep learning libraries or machine learning libraries, but what they really are is libraries that allow us to compute derivatives very easily. And it's being able to do that, being able to perform this automatic differentiation that allows machine learning, including deep learning, to function efficiently. So if you've never worked with TensorFlow and PyTorch before, I might recommend checking out my linear algebra for machine learning live lessons, in which we dug into the basics of both libraries in quite a bit of detail. We're going to jump here now to a point where you already have some assumption about how to create tensors, what tensors are, and how to perform some simple manipulations with them in both TensorFlow and PyTorch. However, after this demo right now, we'll actually move forward just entirely with PyTorch, since it happens to be my favorite of the two libraries. But if you already have some understanding of TensorFlow, it shouldn't be difficult for you to convert any of the things that we do in PyTorch over to TensorFlow following these code demos that I carry out right now. So let's use both libraries to calculate dy dx at the point where x equals 5. Let's do this really simple equation here, y is equal to x squared. And we know from the power rule that dy dx is then equal to 2x. And so if x is equal to 5, then the slope dy dx at that point is equal to 10. All right, PyTorch first, since I think it's a bit easier, it's a bit more fun, and it's the library that we'll be continuing onward with. So first we import torch, and then we create a variable x, and this variable x has the value of 5 because that's what I specified in this little calculation here. We can have a look at it. It's just a scalar. It's critical here that you create a float precision tensor, so make sure that you include a decimal. The next step for performing differentiation with this variable x is to use this requires grad method, which sets this argument on the tensor to true, this requires grad argument. So this enables us to track gradients, to track slope through a forward pass, and it's contagious, which means that other variables that interact, other tensors that interact with x through the mathematical operations that we chain together, those other tensors, those other variables will also have require grad on. Nice, so now that we are tracking gradients, we can perform our forward pass, which is very simple. It's just, in this case, y is equal to x squared. So let's perform that computation. And now, to actually apply Autodiff, now that we have put require gradient tracking on, we've performed our very simple forward pass, we can now perform what's called a backward pass, which is the automatic differentiation. So what this does is it goes backward over our forward pass, starting with y, and in this case, it's very simple. It just has one operation to work through, but we could have many, many operations chained together in our forward pass. Again, in this case, it's just super simple. It ends right here at the variable x, but it calculates the gradient dy dx. So as we calculated by hand earlier, we know that at x is equal to 5, with x equal to 5, dy dx is equal to 10. And there you have it. Nice. So having done that in PyTorch, let's do the same thing in TensorFlow next.